The evaporative emission system, sometimes abbreviated as EVAP, consists of the fuel tank, fuel cap, vapor storage canister with activated charcoal, canister purge valve, canister vent valve, and all interconnecting lines and hoses. Fuel tanks are also fitted with some type of rollover valve to prevent fuel leakage in the event of a vehicle going wheels up in an accident. A separate fuel vapor separator may be installed that allows vapor to reach the canister but blocks liquid fuel that would damage the canister's activated charcoal filler. The purpose of the EVAP system is to capture and store fuel tank vapors instead of venting them to the atmosphere. Since fuel vapor leaks are a major cause of hydrocarbon emissions, vehicle fuel containment systems are now tested for leaks by an enhanced OBD2 monitor. A failure in the EVAP system can store a DTC and trigger the mill, causing the vehicle to fail an OBD2 emissions test. Enhanced EVAP systems check for leaks 20 thousandths or 40 thousandths of an inch in size. The original 40 thousandths inch leak specification used with early enhanced EVAP has been tightened to 20 thousandths inch in recent years. Three basic types of tests are used by onboard monitoring to detect leaks. The first is vacuum testing. There's pressure testing. And finally, natural vacuum leak detection, the most recent form of leak detection available and something we'll cover in more detail later. In all three types of testing, a pressure sensor is placed somewhere in the fuel system, commonly at the fuel tank. By measuring pressure changes, the onboard system can determine if the canister purge is working properly, if the canister vent is working properly, and if the system has a leak. Here's a brief generic strategy describing how engine vacuum is commonly used to test for leaks. Let's look at main components of this system. A purge valve is placed in the line between the canister and the engine vacuum source. This valve is normally closed and is opened by a signal from the vehicle computer whenever it wants to purge fuel vapors from the canister to a running engine. This is no different from purge valve operation before OBD2. A solenoid-operated vent valve is located in the canister vent line to the atmosphere. Unlike the purge valve, this solenoid-operated valve is normally open. The addition of the vent valve is unique to OBD2 vehicles with enhanced EVAP systems. This valve allows the system to be sealed for leak detection purposes. Finally, a fuel tank pressure sensor measures vapor pressure inside the fuel containment system. Also referred to as the fuel tank pressure transducer, this sensor's measurements can be viewed in DataStream if the serial data interface supports the PID. To test the system for leaks, the computer first closes the vent valve to seal the system. Then it opens the purge valve, applying engine vacuum to the EVAP system. If the pressure sensor detects sufficient vacuum, the gross leak test passes. If no vacuum develops because of a large leak in the evaporative system, a gross leak DTC is stored. This is the code that turns on the mill in some vehicles when the gas cap is left dangling on the quarter panel from its tether. Gas fill caps have been modified in recent model years to make them easier to tighten. Early OBD2 vehicles with hard-to-tighten gas caps stored many EVAP codes for gross leaks. If the system passes the gross leak test, the small leak test begins. During the small leak test, the vent valve remains closed and the purge valve closes as well. Closing both valves should seal the system, trapping any vacuum in the system left over from the gross leak test. Now the vehicle computer monitors the pressure sensor reading again to see if the vacuum trapped inside the system holds steady at a specified level for a specified time. If vacuum holds, the system passes the small leak test. If not, a fault is recorded. The second type of onboard evap leak test uses pressure, not vacuum, to test for leaks. Vehicles that test for leaks this way are equipped with a vacuum-operated pressure pump, also referred to as a leak detection pump or LDP. The pressure pump operates long enough to apply a test pressure to the system of about 7 inches of water. This is a very small pressure, equal to about 1/4 pound per square inch. The length of time the pump runs to reach the test pressure and the frequency of pump cycling are both counted by the onboard monitor. For example, if the pump runs a long time to build up test pressure and then comes on again frequently to maintain that pressure, a leak is detected and a fault is recorded.